So welcome back. It's 3 o'clock, and we move now into this session, Data and AI Technologies, Challenges and Present. Something, please leave the slides. Yeah, thank you. And present cutting-edge approaches. Just a few messages before we start. First, we didn't take the group picture, but we will do in the next break, so we'll give you details later on. Now, content-wise, so this morning we covered a lot the topic of the SMEs. Very interesting panel, also data for trustworthy AI. And now we move into data and AI technologies, very wide topic. But I have to say, if there is something that really, the identity card of this community, something that we do is really to work in this type of challenges, to build strategic agendas for data and AI technologies, and to develop. So the people here, developing these new approaches for data and AI. So really, it's a very important panel for us. We do that in many different sectors. So I would like to thank, before inviting to our moderator, in particular, Tillex from Sintef and Davide Dalle Carbonare from Engineering for putting this session together with Ines. Also, we might have a few modifications in the agenda. Ines will explain, as we had to also make some modifications before, but I leave this to the moderator. And now I want to very much welcome Ines Rito Lima, Innovation Manager at MOC Technologies. Thank you very much, and thank you to all the panelists.
And hi, everyone. Can you hear me? Yeah. Good afternoon, and welcome to our session in Data and AI Technologies. I know this is the session after lunch, so we'll try to make it exciting so that you can keep engaged. As Anu was saying, my name is Ines Rito Lima, and I'm an Innovation Manager at MOC Technologies, which is a Portuguese SME. I also have a background, I also have a background in bioelectronics and computer science engineering, so I must say it's quite a pleasure for me to be here moderating this session where we'll be discussing the challenges, the opportunities, and approaches on data and AI. So today here we have Professor Carlos Sanzoni, Dr. Dumitru Roman, Dr. David Dalle Carbonare, Dr. Oscar Lazaro, and Dr. Roberta Turra. I will later on more formally introduce each one of you, but I wanted to start by thanking you all for accepting the invitation to present and participate in this session. Me personally, I think I speak by the audience that I look forward to hearing your input in these cutting edge areas. I also like to thank everyone in the audience that are here physically, and I think that we are also streaming online, so thank you to everyone who's watching. I think it's great that we are here in person again, and with more or fewer restrictions. I think it's very exciting that we are coming back to these physical events, and I think that we'll make the most of these physical events. Well, in today's agenda, after a brief introduction, we'll have 4 presentations. We might have a few words from the president of BBVA, Thomas Han, and then we'll have, is yet to be confirmed, sorry, and then we have a panel discussion to have a brainstorm of ideas. So as for a brief context, as you all know, we as a society, as a scientific community, as members of a business or industrial players, we are producing more and more data. And I think I could say that we are becoming increasingly aware of the power and of potential of transforming this data into information and knowledge, and how this knowledge can push forward the services and business that we are offered or that we research and sell on a daily basis. Generating and processing AI models based on meaningful data on the computing continuum, so cloud, edge, and fog, can set a new landmark in the research and business opportunity and the exploitation strategies. However, although this vision is becoming clearer and more efforts are being made, I would say individually, corporatively, and in terms of the European Commission, as we heard before, we are still talking about huge amount of data, highly complex, most of the times unstructured or disorganized. So I would say that the challenges of extracting value from data are still manifold. And with that in mind, I would like to introduce our first presenter, which is Carlos Sanzoni. Carlos Sanzoni is currently a full professor in computer science at the Department of Electrical Engineering and Information Technologies here at University Naples Federico II. His research interests cover the areas of image analysis and recognition, machine learning, and deep learning. He is the director of the Federico II node of the National Laboratory of Artificial Intelligence and Intelligent Systems, and is also a member of the Scientific Advisory Board of the Italian NVIDIA Technology Center. In today's presentation, we'll start a discussion about data-centric AI, which is the discipline of systematically engineering data used in AI systems. Whenever you're ready.
Okay. So good afternoon to everybody. Thank you for inviting me in this session. So I'll try to give you the point of view of the AI scientists that work on data. And in one of another session this morning, we already talked about data-centric. So I'll try to give you other hints about this new movement, as one of his founder, Andrew Ng, called it. So here are my address, if you're interested in. I'm also a member of the PICUS lab at my department. So in order to try to give you a very brief history of data and artificial intelligence, I would like to start from the first very model of neuron, since one of the things that I want to say is that the history of artificial intelligence started from model, and then AI models would rise a very significant interest also in society and also in industry, only when significant amount of data become available. This point is also, you can also see something about this point if you consider that the first proposal about one of the well-known deep learning model as a convolutional neural network was proposed in 1979. But obviously, at that time, the availability of a significant amount of data was not possible. Obviously, there was also another problem related to the computational power, since for training such a model, we need obviously a lot of data, but also a lot of computational power. So starting from that year, the model of AI, in particular of neural networks, comes back to quite simple architecture made up of 2 or 3 layers, and give rise to the well-known backpropagation architecture, the multilayer perceptron. That was one of the first model in the neural network field that could be applied in solving real problems. After that, the birth of a very significant amount of data. In 2009, ImageNet was the first large-scale image dataset released and publicly available. You raise the possibility of coming back to the developing and to the possibility of making production wide model, so that in 2012, the well-known AlexNet architectures give rise to the first place in the classification contest of ImageNet database. So from one end, the availability of a significant amount of data makes possible to develop, to properly develop models. But on the other hand, another important aspect is the fact that the availability of a common data set shared among all scientists also make possible to say that the results obtained by such an architecture was really significant, since in some cases in our literature, first model was proposed with reference to quite small set of data. So the generalization of such result was not straightforward. On the other hand, results on 1 million data, as the size of ImageNet, from one point of view, represent a first significant results that can be considered as really significant. So starting from that day, the AI community started in developing more complex model, in the sense that the deepness of such network was increased, starting from the 7-8 layers of an architecture like AlexNet to 1050 layers of ResNet and so on. So in this period, the interest of the AI community was quite significant in the field of developing new models, more complex models. And from a certain point of view, the problem of data, in the sense, the problem of assessing data, of considering a significant data set, was not very crucial in the AI community. Well, in this year, on the other hand, in the scientific community, there is the rise of a sort of a new movement, as I already said, in the sense that from the rise for, and also the rush in trying to developing and to assess new model, the interest is now comes back to data, in the sense that data-centric AI, once again, is at least for a part of our scientific community, one of the principal aspects of our investigation. In particular, this movement was birthed in 2021. Andrew Ng was one of the founders. In particular, in 2021 at NeurIPS, there was a workshop on data-centric AI. As we already said, we can say that data-centric AI is a discipline of engineering in a systematic way the data used to build AI system. So once again, the focus is now once again on data. The centrality of data is once again within our community. And we can say that data-centric AI can represent a sort of the transition from the focusing on model to the data underlying that model. Data that can be used, that must be used in order to train and evaluate the model. So once again, we come back to the need of creating data, in the sense that while in first year, at the beginning of this century, the effort was only on collecting data. So most data is better. Now there is once again the need of, as I already said, of curating data. So there is a real now paradigm shift, at least in part of the scientific community, that related data from several points of view. Obviously, one of them is data augmentation, which is also crucial in the standard deep learning approaches, in the sense that in order to reach significant results in training deep models, data augmentation is very, very important. But anyway, also there are also several ways in which we can augment data. So once again, the focus in creating also the augmentation of data itself. And then there are also some other works about, for example, data measurement, in the sense that in order to assess the quality of data, we also need measure that can say us that, for example, a data set is more suitable for a specific task with respect to another one. So we are seeing in our community, in the scientific community, a very significant interest in this aspect. A final remark is also the fact that in order to have great data, typically we once again need a domain expert. The role of the domain expert in a part of the history of artificial intelligence was more or less neglected, in the sense that one of the key points of a deep learning model was that the features needed, for example, for classification or anyway for performing the task of the network, was demanded to the network itself, in the sense that it was able to determine automatically the best feature for the problem at hand. So in that case, the role of a domain expert was not so significant. On the other hand, in order to reach data that are curated, that are really suitable for the problem at hand, according to my opinion, once again, we need domain experts that obviously are not so simple to find, but anyway are very, very important. Okay, thank you.
Thank you, Carlo. Are we going to have a few words from Thomason? Okay, so maybe we do another one and eventually you'll join. Okay, in that case, I would suggest we proceed for the second presentation, which will be given by Dimitri Roman. Wait a second for your introduction. So Dimitri Roman is a senior research scientist at SINTEF in Norway, which is the largest independent research organization in Scandinavia. Its general areas of expertise is data management, with a focus on carrying out research and developing technologies to help data workers to manage data in a simple, effective, and efficient ways. He has been involved in initiating, leading, and carrying out projects on data management and service-oriented topics. In today's presentation, Dimitri will speak about big data pipelines for the computing continuum, presenting an ecosystem for managing these pipelines based on the Horizon 2020 Data Cloud project. Now you can come. Thank you.
Thank you very much, Ines. Hello, everybody. I'm Dimitri Roman, and I'm happy that the previous speaker mentioned data-centric AI, because I think we have here a solution that could address the problems of data centricity. So today I'm going to talk about the concept of data pipelines, and I will take an ecosystem perspective and also how to manage these data pipelines on heterogeneous infrastructures, what is referred to nowadays as computing continuum. The perspective that we present here, it's from a project which is called Data Cloud. So it's kind of integrated solution for different aspects of data pipelines. So before I go a little bit more in details, what means management of data pipelines or big data pipelines, what are these pipelines? So the concept of pipelines is not necessarily new. It's comprises of processing steps of the data. However, what's different here than typical data pipelining is the fact that here we have to deal with big data. So you have these aspects of volume, large amounts of data, velocity, streaming data, and so on. So to give you an example from manufacturing, you have 1 terabyte of data in a database with sensor measurements. So you would need to take this data through a number of steps, like getting this data. Data can come in high frequency. You need to reformat this data to fit a certain purpose. Then data is too much, you have to split it in chunks. You probably need to clean, add additional data to the original sensor data, and in the end, maybe perform some machine learning training on the data. So the question is, how can we enable the process to from retrieving the data to this ML training aspect, and how can we do that in an inclusive way in the sense of engaging different stakeholders in the process? So what we see is that there are a number of aspects or tasks and challenges related to such pipelines. So the first one is how do we discover this kind of pipelines, or the structure of these pipelines from data that is already there, maybe in log formats, maybe in databases, maybe in different processing system. So once we discover this data, we can this structure of the pipelines, we can refine them, we can add additional steps, additional elements in the pipeline. Then we would like to see how we could execute these pipelines in a way that you do it in the best or in the cheapest way, given the resources that you have available. It can be a continuum of hardware like cloud, edge, fog, and so on. How we provision this infrastructure, how we deploy the pipelines on the infrastructure at runtime, how we adapt, and this basically is a kind of life cycle, a cycle of how to manage this pipeline. So what's different a bit here is also the lower part on the infrastructure, that it's very diverse nowadays. So sometimes you have to process data on the edge, IoT devices, sometimes somewhere in the middle, sometimes the cloud. So these are the type of typical tasks that you do with pipelines. So here we take a perspective of an ecosystem and tool-supported ecosystem. How can we support different stakeholders in getting involved in these tasks related to data pipelines? So typically you have some data providers that have some data, generate data. Then you would have data consumers, on the right-hand side here that want to consume the results of these pipelines. And then you also have the domain experts that have knowledge about how the knowledge of the domain in which these pipelines are identified, developed, deployed. Then you also have the data scientists that potentially instantiate the steps of these pipelines. And you also have the resource providers. These are those that own and want to make available their infrastructure for processing the data. So we envision a kind of ecosystem where these stakeholders can work together, and a number of tools to support different stages of data pipeline. So for example, data providers come with the data. This data takes the form of dark data, data that it's collected but not used, value is not taken out of it. So they would like to get value of the data. So it would go through some sort of process mining pipeline where you try to understand how this data has been generated and potentially processed in the first place. Once you discover this structure of how the data went through, you would involve the domain experts to put some sort of high-level specification mechanisms for configuring the pipelines. So using some sort of domain-specific languages. Then you would involve some data scientists that could populate these data pipelines with doing different steps like pre-processing of the data, attaching machine learning algorithms, different steps in the process, and so on. Once you have the big data pipeline specified, you need to simulate how this pipeline would get executed, how much it would cost to get executed on certain type of infrastructure. So you need some sort of simulator here to tell you what's the best configuration of the hardware. Then you would bring this perspective of resource providers that can come in with untrusted resources, that executing your pipelines on untrusted resources would imply some sort of techniques to ensure certain level of trust. So here we think of this concept of resource marketplace, potentially backed up by distributed ledger technologies. So you'd have all these resources made available for the data pipelines. Then once the resources are there, you'd like to deploy them and actually make them ready for being executed. So all these things are happening at design time of the pipeline, and ensuring that everything is set up for the runtime aspect when all the data will start to come in into the deployed pipeline. This computing continuum will provide some or the system some sort of adaptation in case hardware fails or devices become unavailable, where parts of this data pipeline should execute, and the result will come out some sort of smart data and insights for the data consumers. So all these steps are backed by a number of tools like this pipe, which is a tool for discovery, definition, def pipe, and so on. So we think of this as a kind of toolbox for different stakeholders of this ecosystem. And we have a paper that we published in the IEEE Computer magazine detailing all these challenges with different aspects of the pipeline. So to give you an example where this kind of ecosystem and tools could be applied is remote monitoring of elderly patients. There was a presentation early this morning about systems. So in Norway, we work with a company that has a similar system. So you have elderly people that have all sorts of sensors that can measure, I don't know, heart rate or weight of the patients and so on. All this data goes into a hub, which in this case is a kind of router referred to as the Telu service. And this hub collects the data and partly process the data on this edge device, partly will be sent to the cloud for automating data analysis. Medical doctors and healthcare personnel will be involved in care plan for the patient. So there's some sort of communication between patients and doctors. So there are a number of issues here when it comes to, getting the data, processing the data, where is it going to be processed, and so on. So this existing application that we work with is not designed in the first place as a data pipeline. It's difficult to scale the steps in the pipeline. So if you get more data suddenly, the process will not scale. If you suddenly get a lot of patients, you need to instantiate these pipelines, how to replicate these pipelines for potentially large number of patients. Then also it's an issue with different hardware that is being used here. So how to manage applications on this hardware. And also they don't know like what's the best configuration that I can make it in a way that it's cheaper for the whole process when it comes to use of resources, cloud resources, and so on. So I'll very briefly go through how we apply this. So this is a running demo that we have right now. You have two tasks, design the pipeline and how to distribute the data pipeline in the infrastructure. So there are a number of tasks related to configuration of these the pipelines, how to validate the pipelines, how to scale each step of the pipeline, also bringing in the notion of software containers, how to scale the processing of the pipelines, and so on. So we look through the logs from this edge and cloud system that are part of this remote patient monitoring with this pipe tool. So we try to visually discover pipelines from logs. Then once we have this skeleton of the pipeline, we visually design, adjust the pipeline to ensure that it does what we want. This is another visual tool for specifying these pipelines. Then we try to simulate what's the best, cheapest configuration for the hardware that we will need to execute the pipeline. So we this first stage of designing the data pipeline is done. And then we look into provisioning resources for the pipeline based on the simulation that we did in the step number 2. We will look into the adaptation of the infrastructure and in the end deployment of the pipeline on the infrastructure that we selected. So in the end, we get to the execution of the pipeline that we can use in this scenario for different aspects like scaling and basically supporting the pipelines. Okay, so all these tools that I mentioned are currently being developed as most of them as open source. You can check out on GitHub the tools. There are also documentation that for the individual tools, but also for the toolbox as a whole. So how do we fund this kind of initiative ecosystem, tool-supported ecosystem is through some projects. One of them is the Data Cloud project, which is in the area of cloud computing. It's currently ongoing, about halfway through the project. And the aim here is to develop a software toolbox to support this pipeline life cycle on the continuum computing, and also to show that we can validate this toolbox concept in a number of diverse cases, ranging from digital marketing, live media streaming, electronic healthcare, as you saw the example that I gave, and also predictive maintenance industry 4.0. And last but not least, I would like to mention another initiative that we have in this area of data pipelines, but it's more specifically focused on for the task of so-called data enrichment. So data enrichment is basically you have some data as given in this example, some cities and regions. So you don't know, like Berlin, what it refers to. Maybe it's the capital of Berlin, but maybe other Berlin in, I don't know, USA. So you try to use external reference data sets, like we see here, geonames, to disambiguate this original data that you have and try to extend your data. So from a region, you can get the latitude, longitude by checking, referencing external data sets. And you have issues like how to find these reference data sets that you can enrich your data with, or sometimes these reference data sets are, you need to pay for them. You need to understand that data that you will link to, how to clean this data, integrate, and how to scale the whole process. So the point is from some original data to get to different steps, like in this case, latitude, longitude, but you maybe would like to get also the temperature of those locations, referencing ECMWF, which is a provider of data in for different parameters of data. And once you have this more enhanced data set, you'd like to serve it to a model to do some analytics, machine learning. So this project is about how will you execute all these data enrichment pipeline steps and how you would scale the whole process. And it's a project that will start after the summer. So what from the pipeline perspective, the idea is that we will offer some infrastructure services that support the specification, deployment, and execution of these pipelines. And also a number of tools, again, the concept of toolbox for different tasks that are specific for data enrichment, like data profiling and discovery, access to the data, interactive data cleaning and transformation. So how will you go through these steps of adding data to your data and enhancing the quality of your data in the process? So there will be a number of tools that are depicted up here, and a number of infrastructure services down here that will enable you to get input data, like what you see here on the left, enrich with reference data sets. And through this infrastructure, you will basically get enriched data, higher quality data at the end. So I think I'll stop here. Thank you very much. And hopefully there is some discussions around this.
Okay, not yet. Okay, in that case, we'll proceed to our third presentation by David Dal Carbonare. Wait a second for your introduction. So David is a senior researcher and business developer for the research and development at engineering. He is a member of the board of directors of the BDVA Association, where he also co-leads the Smart Manufacturing Interesting Working Group. He is focused on national and European research projects related to data and AI topics for developing and evolving solutions to be transferred from the research lab to the company business units. In today's presentation, David will discuss the barriers of taking AI use into organizations in order to present methods and tools to how to overcome these barriers. Thank you. The mic is yours.
Thank you. Thank you very much, Ines. I have to say that it is very emotional to be on stage after more than 2 years of remote presentations. Just let me say that. But this time I didn't have to put a nice background, virtual background. This is a real background. Okay, I'm happy to bring now a different perspective compared to the two that we have seen before. We've seen from the academics and from the research. Now I would like to represent more the industry part, and I would like to drive your attention to the important activity to bring AI application in operational environments. I would like just to start setting a bit the context. So where I want to create my business application, defining also my success criteria, and when it comes for me to develop the system, the application that will satisfy my business goal. And it happened that I discovered that it's strongly based on data and AI. I can quite quickly say that the raw steps that I have to take are, I do have to collect data, I have to train my AI model, and then I have to deploy it in production. Is it that easy? No, it is not, because it's definitely an oversimplification. There is much more to take into account, especially when it comes to take the results that you might have developed in your lab and move them into the production stage. In fact, if we look at the entire picture, we see what we thought at the beginning to be the most important piece in the middle, but surrounded by many, many other activities. Titi already explored some of them on regards to the data preparation. In fact, on that side, you have to take care of not only collecting data, but you have to clean it up. You have to prepare it for training, testing, and validating your model. But after the analysis, you also have to take care of the results and to distribute to whoever should take benefits of those. At the end, you need also to take care of the infrastructure, the configuration of the infrastructures that will provide the resources to your application, to your AI application to run in the production environment. And last but not least, of course, you have to monitor the entire system. So now that we had somehow set the context, I would like to highlight some findings from market reports that are involving companies and organizations in the phase of operating their AI solutions. It's an average of 9 months to the organizations to take their solution from prototype stage to the production stage. It's only 1 out of 10 that are able to bring their model from prototypes to production. And for half of the AI leaders, life will not be that easy when it comes to move their AI project from proof of concept to the maturity level that's enough for the production stage. In general, we can say that in most of the cases, the reason for these AI projects to fail is because organizations are addressing AI operationalization too late in the process. Now we look at the challenges that they face. Still, I'm taking from a market survey that is done over the organizations that are running AI solutions in production. And these are just the top 3 barriers that has been collected by that survey. What we find there, we see security or privacy. We see integration issues. So the issue to integrate the solutions that you have developed in the existing infrastructure, and the good and old data volume and complexity. What I would like to take from this list and what can be derived from there is that the main issue is not to build the AI model as someone might think. The real issue is to build the integrated system and to continuously operate that in production. Fortunately, it's not only bad news. We can also have tools and solutions that support organizations in achieving this complex goal. Given that we are talking about AI and data, of course, my first take is on the model ops. That's one of the most recent practices that has been developed together with data ops. Both of them are based on DevOps. That's definitely the older one of the family. It comes from some decades now. But that practice already established at that time the most important pillars on which also DataOps and DevOps are based, focusing on their specific aspects. The 2 more important pillars, at least to me, are automation and collaboration. Nowadays, we still have many activities that are done manually, and they come with their issue. So it takes longer usually to be executed. It's more difficult to have them to be replicated. You inject more frequently human errors inside, and you may experience somehow a lock-in with the team members that you have, because of sometimes you may rely just only in one or few people that over time developed the knowledge and the expertise to execute manually certain operations. Teams are becoming every day more and more multidisciplinary. So you have data engineers, system managers, data scientists. So it's very important for everyone to be able to collaborate for the benefit of the final goal. If we look at the tools available out there, and if we consider DevOps, that is probably the case where we can have more choices and where we can find more mature and stable solutions. That's not the case for DataOps and ModelOps, because of these are actually the years where we can see a lot of development around those topics also, again, as Titi just presented. Actually, also at engineering R&D, we are developing a solution to help users to implement ModelOps practices on their own. Now, just to conclude, I'd like to leave you with just 3 takeaways about the benefit that a company may gain by applying ModelOps practices. One that is probably taking everything is to improve the quality of their overall solution. These are benefits that you can gain by applying those practices and those tools. But most of all, I really want to remind you that the 3 that I have in mind always: to automate, collaborate, and monitor. So these are the basis for having those benefits to materialize. You can enhance the productivity of your data science teams. You can reduce the time to market. Remember the 9 months that we have seen before. And you can do that by automating your activities. You can improve the maintenance efficiency, and you can do that by reusing at most the assets that you develop over time, whether they are data sources, data sets, models, or workflows, pieces of workflows that you can reuse in different applications and different contexts. Those can enable you to scale up from few to thousands of models, because don't forget that When you are in a lab and you are focused on one single exercise, you see only that one. But a company that wants to take business benefit out of those services most probably is willing to deploy hundreds or thousands of models. So you need to be very well equipped. You need to have a framework to follow. You need tools to help you to follow and to master all that complexity. Last but not least, given that most of these operations or activities are very energy consuming, to have an effective resource management can help you or the company to save time, money, and also it may reflect also a positive impact in the environmental footprint of what you do every week or every month. Thank you very much for your listening.
Okay, so I would suggest we move to our last but definitely not least presentation by Oscar Lazaro. Oscar is the director of Innovalia Association and supports innovation transfer towards Innovalia business units. He supported the digital innovation hubs for innovation for manufacturing SMEs program and leads the WEF Advanced Manufacturing Hub. He is a board member of ByData, the Digital Factory Alliance, among other responsibilities. He coordinated the Boost 4.0 BDBA Lighthouse Initiative, and he now leads the Ready Follow-up project. His main area of expertise lies in Industry 4.0, AI, and data-related topics. In this presentation, we'll speak about new data architectures and AI-powered digital twin approaches, which are fundamental and available to realize continuity at such higher levels, thereby leveraging computing continuity from the edge to the cloud.
Okay, thank you, and a pleasure to be here today. And I think the previous speakers did a great job, just introducing the background and the context of what I'm about to present. Because my plan today, at least for the first 10 minutes, is to talk a little bit about digital transformation from the background that the moderator was introducing, that is this operationalization of AI in the context of Industry 4.0. And there is one particular issue that, at least for manufacturing, has become critical. First with COVID, but I would say with many of the different waves of disruption that we have mentioned today. I was remembering a few that Nuria was mentioning in the morning: war, energy, many things that are disrupting. And these are numbers from a very recent study of the World Economic Forum that really provide staggering figures in terms of how disruption and resilience are critical for operations in manufacturing. And actually, what is really important is that to realize this resilience against disruptions in supply chains, raw materials, energy consumption, data is actually critical, but not just data of a single entity, of a whole and complete value chain. And trying to make this connection between sustainability, resilience, digital and data value chains, we have put together a project that is called Ready. It is just fresh from the oven, if you can come fresh from an oven, but yeah, it is brand new. We are just basically started. It is one of the first projects of the twin transition, and it is dealing with the issue of how to deal and how to operationalize. I think, David, you pronounce it much better than I do, or how to bring into practice AI and big data. So with Boost 4.0, that was the previous or the predecessor of this project, we have shown that big data can really make a difference for companies. But it's not enough if we want to work really as ecosystems or value chains. This again is quite a rich consortium. You can translate that for large. So a big consortium of key companies from digital domain, manufacturing domain, research area, pilots, hubs. So trying to bring together some of the technologies and solutions that we have actually heard during the morning. And when we face this issue of resilience, and we face it with the perspective of trying to apply this in manufacturing, we have to understand that the resilience is built actually dealing with two dimensions. You have to be resilient on demand, and you have to be resilient on supply. You have to address both concurrently. And this means, from a business perspective, and this is the way in which we can link with the need for new data architectures and AI practices, we need to be able to respond rapidly. And rapid response means actually actioning models, actioning data that is highly distributed and it is highly heterogeneous for achieving this type of automation or autonomy that we need to build this resilience at demand and supply level. I think so far we are already quite common with this idea of computing continuum, like the resources that we have available. I think our colleagues from Data Cloud, they were talking about this resource marketplace. But if we want to build something like that, we have to bring the continuity concept a little bit higher. We have to bring this to the level of the data thread. We have to build it and connect it with the artificial intelligence and the machine learning models. And at the end of the day, data and models will connect in our digital twins. Okay, and here you can see some of the observations that have been made by the previous speakers. The things we do, we solve them manually. It takes time, it takes money to build all these things. They can be done, but probably not at the scale that we need. So actually what we are aiming at is supporting the data engineering and management autonomy. This is really what we should be able to move forward. And in our vision, when we try to think why we need these data-centric architectures, what we have realized is that we are progressively moving from these connected factories, where we are starting to connect data between some stakeholders, and we are moving more into connecting ecosystems. If I can make a reference to the presentation from our colleagues from TNO in the morning, it is not enough to connect data spaces inside the space itself. More and more, we are connecting data spaces among themselves. So it is not intra, it's interconnection of these data spaces that is creating these new ecosystems. And this brings me to this specific need for new forms of dealing with data. It is not enough to bring data into a big lake. We did already that in Boost 4.0 for many of the use cases. They proved extremely impactful on the business level, and they had been transferred into operation, but they are not suitable for this type of environments. We need not just a digital thread, we need a sovereign digital thread. We need to manage sharing, governance, and management of data. And if we connect this with new approaches for data-centric architectures like data fabrics, what we realize is that we need to move away from raw data and start treating our data as a product. And this is actually what is bringing this capability of the continuity at the level of the digital thread. It brings us to higher applications of those data. Actually, we are not just creating fabrics of data. What we are aiming at is at creating fabrics of executable cognitive digital twins. And later we will see what is behind the buzzword, how we visualize this connection between the actual data and the operation of these cognitive digital twins. But for me, what is important at the moment is that if we want to move into these more complex scenarios, what we have to realize is that we cannot deal with data for every single one of them. We need an approach that we deal with data once, and then we can operate in a number of those data spaces. And for this, the application of data fabric technologies combined with data space technologies are really promising technologies that we plan to investigate in the project. The second aspect is how we are going to combine and how we are going to bring together and to harmonize transactional and analytical worlds. How we are going to build the models, how we are going to deploy these into transactional and operational executable environments. And this is the other part and the other dimension that the project is actually dealing with. How we can create this continuous loop that is connected with some of the needs that Davide was bringing into the table. It's not just enough of building one model. The main problem is how we integrate and continuously manage the evolution of this model with the new data that is being made available. And for this, we are bringing together this reference model that is the one that the project will build, that will start really taking care that the data that we are using is of high quality. And this should has a positive benefit both in the time, speed, and complexity to building the digital twins. But we have to create these 3 or 4 levels of different types of continuums from the computing, the digital thread, the data continuum, and the digital twin one. When we try to build these continuums, we have to bring together different elements because at the end of the day, we are building pipelines. So if we are building pipelines, if we are making accessible different types of data sets, we need marketplaces, we need tools for deal with governance of the data. And this is what the actual reference model is putting together. And just my concluding element in terms of what are the plans of the project, basically at the end, when we want to build this digital 4.0 continuity, what we are aiming at is bringing together these 5 different elements. From the bottom one, so probably reading from bottom to top, to optimize the actual access to this continuum of resources. And for this, we need toolkits, and we need to build on the existing assets of the community. Then work on the distributed data fabric, fairness, quality, sovereignty, and security. And for this, we need to provide tools that make this available. And then we enter into the semantic interoperability level where we have to align and formalize different types of vocabulary. And with this, we can start working with high quality data to build the industrial AI, the federated data continuity that should fit the development of these cognitive digital twins. Which are the pilots that are going to exploit all these tools? Everything is arranged basically in 4 main pillars. So we are looking at different type of applications: automotive, batteries, machine tools, and aerospace. And what we are trying to do is not just trying to optimize the operation of a single machine or a single company. We are looking into the collaborative, connected, cooperative dimension of the value ecosystem. So we are trying to optimize operations at the whole company level with a number of stakeholders that are either engineering, producing, or commissioning different types and components. And when we look at the resilience perspective, we are dealing with both products and machines. So looking at the process resilience and at the machine level process. In implementing this type of pilots, what we want to make sure is that the toolkit that is actually being provided can support this autonomy and resilience across the full life cycle of the product and the process. Thank you very much.
And thank you all for your opening statements. Any news? Okay, so we can proceed. I think that now that we learned about the current technological challenges and how to overcome them, I would suggest we move to our panel discussion and discuss how these approaches can make the transition from research to business, from lab factory. I want to remind everyone in the audience, the coffee had already time to kick in, so feel free to engage and ask questions. In our panel discussion, first things first, the panelists will be joined by Dr. Roberta Turra. So Roberta is a senior data scientist leading the data analytics team in the high performance computing department at Cineca, the major computing center in Italy devoted to scientific research. She is a member of the BDVA since 2014 and an active in the iSpace group since then. She is a member of the steering committee of BIREX, one of the Industry 4.0 National Competence Center, and she is involved in various national and European research projects related to data and AI. I think that now I'm going to move here and make the panel discussion a bit more cozy. I think everyone can sort of mic up. Thank you. So let's get this session started. I would suggest to start by you, Roberta. So I would like to ask, what is the role of infrastructure providers such as Cineca in technology adoption?
Hello, this is already on. Yes. Okay. Thank you for the
I
question.
don't know if it's working, is it?
Okay, more close. So thank you for the question. To provide a direct answer, I can say that the infrastructure providers play an important role in technology adoption among companies, and in particular by providing an environment where companies can test the technologies. And Cineca is, for those who don't know Cineca, it's a consortium of universities. It has been built in 1969 in order to provide computational power to the universities and storage resources. And it is devoted to support the scientific research and innovation with computational power. And so it is the major Italian HPC center, high performance computing center. And we will have, and one of the major also in Europe, and we are going to install by the end of this year, the Leonardo machine, which will be a pre-exascale machine. So we plan to have this machine located in the top 10 resources in the world. So in November, we will have this classification. And it is expected that will be among the most powerful, among the 10 most powerful computational infrastructure. So what are we going to do with this amount of computational power? We as Cineca are doing technology transfer, and we are supporting companies traditionally in the field of simulation. So traditionally, we develop a proof of concept for companies in order to take advantage of the big amount of nodes, of computational nodes, to be more effective in the simulation in computational dynamics, for example, or molecular dynamics. But in the last 8 years, so since 2014, we've been also developing a proof of concept and experimentation in the field of machine learning and data analytics, deep learning, and artificial intelligence. And in this domain, there are two typologies of experimentation that are asked from the companies and that we provide. One typology is a company that doesn't have inside expertise in data science, So they don't have the expertise to do machine learning and to build their own model, but they have collected a huge amount of data and want to get value out of them. So in this case, we provide a counseling service and we develop a model, we develop machine learning model for them or help them to find their solution, given their data and their business problem. And in high performance computing comes into help, especially with deep learning, because you can explore in a very effective way many different architectures using different computational nodes. So identify the best architecture of the network in a very efficient way. And the other typology of experimentation that we host is when companies already developed their models, so they have their machine learning expertise inside, but they needed to improve the performance of this model. So here, the high performance computing comes into play in order to parallelize the algorithm and be able to scale the application. And the application can be scaled on the data side, so increase the number of data, the quantity of data that are used and that can improve the accuracy of the model. But scale can be applied also to the model itself, so the complexity of the model, so increase the number of hidden layers. In any case, I can say that this latter typology of application is the one that is mostly requested in our experience of Cineca. And we are independent from vendors. We don't have any technology provider that we are linked to. So this is an important aspect. When we do advisory service for companies, we are totally independent and unbiased. And so coming back to the question, the company can test new solution, new technology, cutting-edge technologies, by using the infrastructure that is provided not only by Cineca, but by all the DIHs, all the DI spaces, because any DI space, even if not high HPC space, but any DI space has an infrastructure for doing testing and experimentation, and they have data services. And data services are technical services, training, and business development, so that companies can test these new technologies and learn how they can build business around it. Thank you.
Thank you. Very interesting. I think it's a very relevant initiative, a lot of resources, a lot of potential. In that case, I think I'll proceed to another question to you, Titi. Following your presentation, we can say that management is ubiquitous in data-driven activities. So I would like to ask you, what would be examples of and challenges in modern data management?
Okay, that's a very tough question. Well, data management, includes a wide variety of tasks, so it depends a bit on what is meant by data management, but assuming it's the whole value chain from data collection, aggregation, preparation, storage, access, support for analytics and sharing of the data. So I think one thing that has happened is the diversification of technologies and how to navigate this whole landscape of technological landscape. Take, for example, data storage, which is essential aspect in data management. So for many decades, the relational model was dominant. So you only had relational databases, basically. Now for the last decade or so, you have so many types of databases, graph databases, key value stores, then the databases on the cloud. So you see, it's so diverse landscape of technology that it's a challenge, to decide which, technology suits for my task at hand. Then another thing that I see is diversification of the actual infrastructure. So it's you have cloud, you have IoT devices that both, process, collect data. So the question is, where should you do what tasks? For example, there are cases that data is coming so fast. Think of sensors installed in factories. These sensors are connected maybe through Wi-Fi, but the data comes so fast that Wi-Fi cannot pass the data to a centralized cloud storage, let's say. So it's this, how do you handle this very heterogeneous infrastructure in terms of data, processing the data, where, how, and so on. So then it's a question of how to make all these technologies and infrastructure, easily accessible to different stakeholders. There was mentioning of domain experts, the role of domain experts, both in data, Centric AI, and also in Davide's presentation. So how can you make all these technology stacks, more inclusive for this kind of stakeholders that are not necessarily very IT inclined personnel. So that's another big issue, I think, how to make the technology stack more accessible to different stakeholders. Then I also think there are issues related to data access. So there's all this legislation with GDPR, processing of data, what you can, what you cannot do. But there's also like issues related to data locality now. You can store in this cloud, but which is in this location, not in the other location. So, taking this legal or regulatory perspective in the data management process is also not an easy task. And maybe last but not least, I would like to mention the cost. So we talk about technologies here, but in the end, to use these technologies, when you have data, it will cost. And if you look at cloud providers, just look at data storage, like storing your data in the cloud. To take out your data from a cloud provider costs immensely. Of course, depends on the size of the data. But using all this technology, it comes with a cost. And how can you optimize your data management pipelines or data management tools in a way that you can reduce the cost? It's not an easy task. Like nowadays, if you, let's say, have an application and you want to deploy it on one or several cloud providers, maybe internal infrastructure, it's so difficult to, calculate what will it cost me, because the cost in these providers always comes after you use it, not beforehand. And it's so complex, the cost schemes that, like, again, how do you match the need with trying to understand the cost models and optimize that? So just maybe to summarize, I think it's diversification of technologies, of infrastructures, how to make this whole thing easier and cost effective.
Thank you. Still a lot of challenges and research project opportunities, let's say. Okay, so I would like now to switch a bit, you never know who's next, to Oscar and ask which other different dimensions should we consider to develop data as a product paradigm in the near future?
Thank you for the question. I think it is a little bit exploratory because it's something that, as I was explaining, it is something that we will deal with in the next months and years. But one important thing, I believe, when you start looking at data as a product, so you take this data-centric perspective, I think we are departing from some models that we have implemented so far where we have tried already to connect the different silos that we had inside the factories themselves. I think that this has been one of the main challenges that we have had over the last years, trying to connect all these silos. But when you think at an ecosystem level, then you have the next level risk that you connect all these silos, but then you create a new bigger silo. So it is like this exa computing machine that Sineca was bringing. There is always more power to compute, but also with data spaces, we have this risk that we create a very big silo that is the data itself, the data space itself. So we have to understand that if we don't look into the quality of the data, into the models that we use to build this data that is creating the fabric, we are in principle creating already by design this type of silos. That is why I think what the colleagues from TNO were highlighting before, this interoperability inter-data spaces that very much connects with how we start building a data that can be shared and reused, that I can put in practice into one of these data spaces and immediately can be accessed, because both the semantics of the data and the structure of the data itself as an object is known and somehow harmonized. I would not say standardized, maybe that is too much of an ambition, but at least there is some common understanding on how we build things.
Thank you. I think it's quite an ambitious idea, but at the same time, down to earth, like reasonable. Okay, so for the sake of symmetry, I'll now move on to you, Carlo, and ask you what's your opinion on can we create common curated data sets that are crucial in several fields, for instance, the medical one?
Yeah, thanks for the question. Well, maybe one of the possibility is to work maybe at regulatory level, maybe at government level, in the sense that maybe for example, in the medical domain, there is also the need of some act at government level in order to provide a common data set, since at least from the research point of view, but also for company. Now it's quite difficult in Italy to work. Obviously, it's difficult to work without data, but also sharing data is not so simple. So from one end, a possibility is to use some sort of digital twins. From this point, maybe also artificial intelligence can help, in the sense that model like GAN, so generative adversarial network, can be used in order to create data that are very realistic but are not related to someone. So this could be a possibility to overcome the problem. On the other hand, if at least at national level, but maybe also at the European level, it is possible to act at a more higher level, so a government level, maybe it would be possible to create some common data set that are crucial for benchmarking application, since, as I mentioned before, one of the problems that several models, several algorithms are presented or tested on to limit the set of data. So we cannot ensure the generalization capability of such a model. So there is sure such a kind of need. Another possible solution in order to ensure privacy, which is one of the problem now, maybe could be also use of some techniques like federated learning, since also in this case it is possible not to share data, and then once again it is possible to have a way in order to ensure and to evaluate in a proper way the capability of the model. A final remark regards the role of some consortium like CINECA, in the sense that the computational power of such consortium also can be very important for also for university, since the model presented by Roberta was also used in our university, in the sense that also in our case, the possibility of using this computational power could be, and also was important in order at the first level to start to work with deep learning algorithms, and at the second moment, when we have models, when we have the capability of working on these models, also to use the high performance computing capability in order to train in a quite reasonable time the developed models.
Thank you. It's never like a one-man show. It's always required like cooperations and multidisciplinary approach, so it makes sense.
Who's next?
You guys. Okay, so David, sorry, you talked a bit about model ops and data ops. So I would like to ask which are the most promising evolutions enabled by this model ops and data ops in the near future?
Okay, yes. Let's say in the near future. I will not look too far, otherwise we should need a crystal ball. Okay, so, but I would bet on a couple of things. Augmentation and citizen data scientists. They are also somehow related. I go back again to one of the repeating concepts that I explained before, that's very much related to the monitoring part. So being able to collect measures from the environment, but not only from the environment that you use in production, to collect measure all along the process, starting from the design, testing, deployment, and much more in operation of an AI system, of an AI service, of an AI application. At the end of the day, this will help you to collect a lot of information that you can translate in a knowledge base. You do a collection of all the trials that you do, all the configuration, the changes that you do, and this will reflect later on, once you are able to apply again AI to support yourself in doing your work. If you consider, for example, just one, the activity of the feature selection, when you have to start, when you approach to train a model, you can face very complex situation. But if you have a knowledge base with an AI model that can maybe explore the raw data that you are starting from and start to propose possible solutions, this may not solve the problem immediately, but this will give your team a starting point that helps you to save time at the beginning, and you can maybe start focusing more on which may be the proper result or the proper value that you can take out of the data that you have. Or again, for example, for exploratory activities on data, you collect many raw data and you want to know, the data tells you what they have inside. So that's also a very time-consuming operation, but it's possible to not to fully automate, but to have that activity supported by this kind of technology, by augmentation. The same may be applied, for example, for proposing which are the candidate models to be trained, which may be the proper AI solution to try to apply. And on the other hand, I mentioned also the citizen data scientists, because of that there are situations where there is really a shortage on the real data science. That these are not two. These are complementary roles. It's not to say they are replaced by citizen data scientists. Usually are those that are maybe a bit less trained on the technical aspects, on the theoretical aspects, but they are balancing that with more knowledge on the domain, on the business aspects. So they maybe know more on the real business that they have to address with that service that is going to be developed. So having them supported by augmented services, there you can have, and by having a situation that is very well promising from my point of view. And
Definitely sounds very useful and promising. Let's hope your vision becomes true.
thank you.
Okay, I think we covered a bit of each panelist's presentations. Is there any question from the audience? Come on, guys. Anyway, that is amazing.
Thank you. Honestly, I have two questions. One question is for the Professor Connell. As you mentioned about the AI training or industry trend is from the model century to the data century. But so far is another voice that it should be taken as a task. It's a century. So what's your opinion? It means it's a big task and a small data. So this is or what's your opinion about that? I have two questions.
It's a very important point in the sense that in the first part of the research, the advent of deep models was raised from the availability of a very significant amount of data. On the other hand, when we have small data, obviously the problem is quite different. And then maybe in this case, we can also use, in some cases, obviously, models already developed for other data which are quite similar, in the sense that in this case, knowledge transfer or other kind of possibility could be a solution. But anyway, in case of small data, maybe the problem of the quality of data is more important, since in this case some biases can rise, and while in a very huge set of data, maybe at least from a statistical point of view, we can think that some bad things disappeared. When we have small data, obviously we have to take care in a more significant way. So in this case, all the procedures for data quality are more and more important and must be so taken into account in a more significant way, according to my opinion.
Okay, thank you. And the second question is about the I40Y. And in your presentation, I noticed that it have some different organization of the partner involved. But in future, what's the relationship of this project and the GaiaX, especially in the cloud level side?
I think actually GaiaX should be one of the technologies that one of the infrastructures that we should consider to support, because at the end of the day, what we are talking is about highly federated environments. So the infrastructure where all these data could be actually processed and analyzed, they should take, and it should take advantage of GaiaX, and this is one of the things I didn't mention it explicitly in the presentation, but it is one of the challenges that we have to align with previous work that has been performed by not only GaiaX, I would say, by the alliance itself. So the Data Space Business Alliance, and I think it would be a big mistake if we forget about the previous results from FIWARE, BDBA, IDSA, or GaiaX. So this type of toolkits should support the development and connect with initiatives like the smart data models that FIWARE are promoting, or other type of standardization activities around the semantics for Industry 4.0.
Thank you. Any more questions? I'm missing everyone behind that. Okay, anyway, I think we're getting towards the end of our time, so I would like now to thank our panelists for their time and very interesting presentation. I think you brought to the stage very relevant topics. I also want to thank everyone in the audience and who might be watching remotely. And I also would like to thank TILEC in collaboration with David for their extraordinary work in organizing this specific data and AI technology session. With that being said, thank you. I look forward to another session like this.
Thank you, Ines, and thank you, Titi, Carlo, Davide, Oscar, Roberta, and also Till. Has been a fantastic session. I didn't mention that, but we will take input that was given today to our road mapping activities in BDVA. And Davide and Till knows that we are here in the process of building our new roadmap. So it was really great and very data centric all over the place. Very good. So please, now what we will have now is a very short break. There is no coffee break, oh, sorry, but it's done a bit on purpose because we don't want to finish too late.